So we shall continue the next session. These also based on the elimination of arbitrary constant. So already we saw the problem number 2 and 3. So now we shall go through the problem number 4. Find the partial differential equations of all the planes having equal intercept on x and y axis. So there is no equation is given. So in that equations they will be asking plane having intercept on x and y axis. So these are given conditions. So based on these conditions we can rewrite the equations. That means intercept from the plane is x by a plus y by b plus z by c equal to 1. That is a intercept. The equation of the line is x by a plus y by b plus z by c equal to 1. So these are equations. So in the equations we have to eliminate a, b and c. In previous problem we saw how to eliminate a and b, only the two arbitrary constant. So in this sessions here is we have three arbitrary constant. So how we can eliminate three arbitrary constant by using partial differential equations. So here is given is equal intercept on x and y axis. This the wording is given. So equal intercepts. So all the equations of all planes having equal intercepts on x and y axis. So equal means the point must be equal. So given a equal to b, that is a equal intercept, or we can take b equal to c also. So whatever you are convenient, we can take that one is enough. Here is I can take a equal to b. Okay, therefore these equations can be written as x by a plus y by a plus z by c equal to 1. So replace a equal to b. That means I can replace b equal to a here. So differentiate with respect to x we get. So differentiation of x must be 1. So 1 by a plus y by a is constant term. That one is 0. Then that is a function of x and y. Don't treat as this one is equal to 0. That is not equal to 0. This is not a constant term. So that is a function of x and y. So differentiation of z means we get 1, that is dou z by dou x, then 1 by c. Here is we can write. That means again I can tell here, differentiate with respect to x we get from these equations. Differentiation of x is 1, so we get 1 by a plus this one is 0. Next plus 1 by c can write as it is. Differentiation of z with respect to x means dou z by dou x, that is equal to 0. Differentiation of 1 is 0. Therefore 1 by a equal to minus 1 by c into dou z by dou x, that is equal to minus 1 by c into p. What is p here? Dou z by dou x is nothing but p. Next, differentiate partially with respect to y we get. So with respect to y means x by a is constant term, that one is 0. With respect to y means we get 1. So 1 by a plus again I can write 1 by c as it is. Then differentiations with respect to z means we get dou z by dou y equal to 0. Therefore 1 by a equal to minus 1 by c into dou z by dou y, that is equal to minus 1 by c into q. What is q? Dou z by dou y is nothing but q. This is 1 and 2. So equating 1 and 2 we get. So minus 1 by c into p equal to minus 1 by c into q. That means 1 by a equal to 1 by a. So your LHS must be equal. So we can equating these two. We get minus 1 by c into p equal to minus 1 by c into q. Then cancelling 1 by c and 1 by c. Therefore we get p equal to q. So this is a very important problem. So intercept the xy plane means, so these are equations of the line intercept x by a plus y by b plus z by c equal to 1. Then this one is given, x and y are equal, therefore a equal to b we can take, then replace, then as usual procedures we can find the solutions. Next, problem number 6. So eliminating the arbitrary constant from the given equations, x minus a whole square plus y minus b whole square plus z square equal to 1. So differentiate with respect to x from 1 we get differentiation of x minus a whole square is 2 times of x minus a plus then y minus b is constant term, that one is 0. What is the differentiation of z square? 2z into dou z divided by dou x equal to 0. Okay, then cancelling 2 to here, x minus a equal to minus 2z into p is nothing but dou z by dou x. Therefore x minus a equal to z minus zp. We can take equation number 1. Then differentiate partially with respect to y we get. So what is with respect to y? The first term must be in 0. Then second term is 2 times of y minus b. Then with respect to z means 2 times of z into dou z by dou y equal to 0. Then cancelling 2 here, we get y minus b equal to minus z cube. This is equation number 2. So equating 1 and 2. So z minus p and z minus cube. That means x minus a equal to z minus of z p, y minus b equal to minus of z cube. Then from 1 and 2 we get, so z minus a, that is z minus p whole square plus z minus q whole square plus z square equal to 1. So substitute these two equations 1 and 2 in original equations, we get the required solutions here. Then here is we can take z square outside, so we get p square plus q square plus 1 equal to 1. So these are required solutions. Okay, then last problem is eliminating arbitrary constant z equal to x plus a whole square plus y minus b whole square. So same ditto here, differentiate with respect to x means dou z by dou x equal to, so sorry, this one is cube, so 3 times of x plus a whole square, then this one is 0. That is p, we can take 3 from your LHS side, so we get p by 3 equal to x plus a whole square. Then differentiating p with respect to y, we get dou z by dou y equal to 2 times of y minus b. So again, what is dou z by dou y? That is 2, that is q. So q divided by 2 equal to y minus b. So replacing these two values from original equations, we get, so p by 3 whole cube plus q by, sorry here. So equating this 2 in equation number original equations, we get p by 3 into root of p by 3 whole cube plus q by 2 whole square. Since here is we have only square term, so I need the cube term is again we have to multiply one value, so we get p by 3 into root of q by 3 whole cube plus q by 2 whole square. Then expand this one, we get the original solutions. Okay, so this is our last problem. Eliminating arbitrary constant x minus a whole square plus y minus b whole square equal to z square into cont square alpha. So first we can write x minus a whole square plus y minus b whole square equal to z square cot square alpha. Differentiating with respect to x and y, we get 2 times of x minus a equal to, here is 2zp into cot square alpha. This is a constant term, p is nothing but dou z by dou q. Cancelling 2 to x minus a equal to zp into cot square alpha. Next, differentiate with respect to y, we get 2 times of y minus b equal to 2 times of z into q cot square alpha. Cancelling 2 to, we get y minus b equal to zq cot square alpha. Then substitute this value from given original equations, we get z square p square cot power 4 alpha plus z square q square cot power 4 alpha equal to z square cot square alpha. So cancelling z square and cot square alpha, we get p square cot square alpha plus q square cot square alpha equal to 1. So this is a method to find the elimination of arbitrary constants. Okay, thank you.